Hi, in Hazard 2 mini lecture, the analytical method to detect and eliminate hazard from the Boolean output function was presented, and this method allows for very detailed description when, on which conditions the hazard occur and with respect to which input. If your task is only to detect the general detection of if there is a hazard or not, and to eliminate it, the K-map method is more useful because it is faster, much faster than the analytical one. And the first step to use this method is to construct the appropriate K-map. So we put the input variables into the map. Okay, 0, 0. We must use, as you know, K-code. And you must think about ones, because you've got the sum of product version. So the first product is this. So the function is equal to 1 when B is 1 and C is 1, where there are cells with these values of CC is equal to 1 in the last two rows, and the B is equal to 1 in the middle two columns. So 1, 1, 1, 1, it is the representation of this product. Okay, B and C for all of these are equal to 1. That's why the product is equal to 1, and independent of these values, Y will be 1. And let's localize this, not A, so A must be 0, two first columns, sorry. And B is also 0, so only single, the first column on the left, and the D equals 0, the first and the last. D equals 0 here and here, and D equals 1, 1 here and here. So 1 and 1 must be put here. It is, it's this product. A 0, B 0, D 1, two cells, and two cells for this product. A 1 to these two columns, B 0 on the last one column, and C0. Okay, B0 and C must be equal to 0. So C0 is in these two. So I hope I've made it correctly. And the remaining cells in the table are zeros. So let's repeat this procedure in the opposite way, how these values, this expression was obtained, just in this way. Just in this way. This is BC. This one is not A, not B, D, and this one is A, not B, not C. But looking at the neighboring ones, there exist neighbors not being in the same group. Okay? And this is the hazard detection. If you can find, let's focus on these two ones. They are neighbors in terms of K-map method. Okay, they have a common edge, but they belong to two different groups. It is the condition for hazard. Static hazard will occur. To eliminate this hazard, you simply must put them in another group, in a common group. Of course, using the rules you know. You must glue as many ones as possible. In this case, only two are possible, and only powers of two ones can be can be glued together. And from these, you must add this element, this product, to the resulting system. And as you can see, you've got not A, because A is equal 0, C and D. It is the elimination of the hazard which results from this. And let's look for another neighbors being in the different groups. Yes, I can see them. They are here. Let's change the... let's stick with green. This is this one, and this one. These two ones. So they are neighbors, toroidal neighbors. As you remember. So the second term, the second product to be added to eliminate the hazard is not C, D, and what about A? First A, not B. So it is not B, not C, and D. And these are exactly the same two products we have introduced when discussing analytical method. So, and this is very, very fast method. First, only to detect and to eliminate, okay? Without having more detailed description when to test, when you can observe, what to put on BCD, what values to have the hazard with respect to A. The analytical method will allows you to do it. In this case, it is more difficult. It is also possible, but you must go more deeply in this method, and you can do it by yourself by searching the internet. But for the course, for the test, and for the exam, it is enough to detect and eliminate using K-map. Thank you.